Hi guys, so today we're going to do a couple of formulas that you may have done in middle school, midpoint and distance formula. And the midpoint formula right here is, it's a coordinate, x comma y, and you find the midpoint between 2 points on a graph by averaging the x coordinates and averaging the y coordinates. So for example, in the x direction, this line segment goes from here to here. So if I find the middle of that segment in the x direction, and then I look at the y values from here to here, and I find the middle of the y values, I have found the point in the middle. So average the x's and average the y's, and that'll be your point in the middle. Okay, so for this particular problem right here, I can make this x1, y1, x2, y2, and then I can just plug it in this formula. So my point in the middle, it's going to be a coordinate like this, an ordered pair, right? So x1 plus x2 over 2, comma, and then y1 plus y2 over 2. So then I can reduce this. This will be 10 over 2, which is 5. And this will be negative 1 over 2, which I can just leave as negative 1/2. And that would be my midpoint. Now, what if they give you the midpoint and one of the endpoints, and you have to find the other endpoint? There's a couple ways you can think about this. One is just to think about it algebraically, the way this formula is laid out. For example, take the x part of the equation here, or not equation, but formula, x1 plus x2 over 2. And set that equal to 7, since we know that's the midpoint. Since I have one of the endpoints, this could be my x1, y1, but I don't have x2, y2. That's what I'm looking for when I'm looking for the other endpoint. So x2, y2 is the other endpoint of this segment. Okay, so imagine you've got a segment with W at one end, X at the other end, and then the midpoint is M. I can put marks in there to show that that is a midpoint. And I have the midpoint, and I have the X coordinates, but I'm looking for the coordinates on this end. I'm looking for this coordinate. So if I were to just look at the X part of this equation, I could say, okay, well, I've got one coordinate, negative 1, but I don't know the other x coordinate, right? x2, that's what I'm really looking for. But I know that when I average these two, I should get 7, right? Okay, and then likewise, I can set up another equation for my y coordinate. So let's see, y1 plus y2 over 2, I've got y1, but I don't have y2, that's what I'm looking for, but I do know when I average them, I should get the y coordinate of this midpoint. So I can set that equal to 1. And I can solve this algebraically. So put this over 1, now I've got a fraction equals a fraction, and I can cross multiply, right? So negative 1 plus x2 equals 14, that's just from cross multiplying. And when I solve for x2, add 1 to this side, I'll get 15. Same with over here. If I put this over 1, I've got a fraction equals a fraction, and I can cross multiply. So 5 plus y2 is going to equal 2. And then when I subtract 5 from both sides, I get negative 3. So there's my missing endpoint, 15, negative 3. And I would write that as an ordered pair, like I did here. So 15, comma, negative 3, okay? Another way you could do this is, rather than doing it algebraically with the formula, some people like to just look at the visual representation here. Of course, this isn't on a graph, but I'm just kind of lining up my midpoint with my two endpoints. And if you think about it in terms of x and y, to travel from this endpoint to the midpoint in the x direction, I had to go from negative 1 to 7. So how did I go from negative 1 to 7? Well, I must have added 8 in the x direction. Well, if I do negative 1 plus 8, I get 7, but that's only halfway. That's my midpoint. So now I need to add 8 more to get to the other endpoint. So if 7 is halfway and I add 8 more, I'm going to get 15, right? And likewise for the y coordinate, if I were to travel in the y direction from the endpoint to the midpoint, I'm going from 5 to 1. So how far did I travel in the y direction? I must have traveled -4, but that's only halfway there because that's the midpoint. So if I subtracted 4 to get to the midpoint, then I need to subtract 4 more to get to the other endpoint. So 1 minus 4 is -3. And you can see I got the same answer here as I got here when I did it algebraically. Some people just like doing it this way a little more visually and some people like doing it more with a formula. So it's up to you. Okay, we also have our distance formula. Here is our distance formula right here. It's a pretty long formula. Got this big long square root, and we've got to make sure that we do our order of operations. Like I have to do what's in parentheses first and then do my exponents and then add all this together before I can square root the whole thing. So it's kind of got a lot going on here. This formula was actually derived from Pythagorean Theorem. If you want the distance between 2 points on a coordinate plane, right, think about this distance being the hypotenuse of a right triangle. So I can create a right triangle sort of like this, okay? And then I know a squared plus b squared has to equal c squared, okay? Well, if you square both sides of this equation, basically this will be d squared, and the square will cancel the square root on this side, and this looks like a squared plus b squared equals c squared, right? So you can see this is where the formula actually comes from, is from Pythagorean Theorem. So a squared that I've marked here is actually the difference in the y's, b squared is the difference in the x's, and that equals c squared, which is the hypotenuse that they've labeled d right here. So that's where that formula comes from. Now what they did here is they got down here to square root of 52 and then they put it in the calculator. And if you do that, because this is an irrational number, you're going to get a decimal that goes forever and never repeats itself. So that's not a very accurate representation because we have to round it to write as a decimal. So we're not going to do that. We're going to just leave it as a radical. But if that radical can be reduced, we do want to reduce it. So, so rather than, changing it to a decimal using a calculator, we're going to take that square root of 52. We're going to try to break it down. I know that that has a perfect square in it of 4. That's 4 times 13. And since 4 is 2 times 2, those 2's can come out of the radical. Of course, the 13 is still stuck under the radical there. So we're going to end up getting 2 root 13 as our final answer here. Okay, so we do want to make sure we reduce the radicals, but don't change them to decimals. So let's look at this one. I'm just going to label my points, my x1, y1, my x2, y2, and again, just, plug it in this formula. So find the length of QR, that would be the distance d, right? Or, if we want to write the length of QR symbolically, we would just take the bar off. That means the measure of the segment, right? Measure of QR equals, okay, and now I'm going to plug in my points. x2 minus x1 squared plus y2 minus y1 squared. And again, we have to make sure we're doing our order of operations. So let's do what's in parentheses first, right? So this will be a -5, and this will be a +5. And then we have to do our exponents. So if I square this, the negative becomes positive, and this one is also, they always square to positive, right? Because you're squaring both of these to positive and then adding, you're always taking the square root of a positive number here. So if you ever find yourself taking the square root of a negative number, you know you've done something wrong. Okay, so then I can add, so this will be square root of 50, and then this is my answer, but I want it in reduced radical form, okay? So I'm going to go up here and take this 50 and break it down. I know it has a perfect square of 25 in there, right? So those 5s can come out. The 2 stays in. So 5 root 2 would be my final answer for the distance or the measure of this segment, or the length of that segment, the distance between those 2 points. Okay? All right, so let's look at this next page. This is Pythagorean Theorem, and I already showed you how that connects with distance formula. There's a couple of examples here. We can do some here. This one shows you more how to keep the radical and reduce it. That's what we're going to be doing in our delta math problems. Remember that C always has to be the hypotenuse, the side across from the 90. Okay, so that one has to be C, and it doesn't really matter which other one is. You could have A and B or A and B, it doesn't matter. So I'm going to do x squared plus 5 squared equals 8 squared to set up the Pythagorean theorem with this problem. And this will be 25 equals 64. Okay. Oh, I lost my calculator. There it is. So we will do 64 minus 25 is 39. And then we can square root that. We can try to break this down. This is 3 times 13. Both of those are prime. So we can't really, there's no pairs in here. So you can't really break that down. So root 39 is going to be our answer. Okay, now this one is kind of a fun one because we have this binomial going on here for our hypotenuse. Again, that's across from the 90, so that's our C, so ABC. So let's do x squared plus 9 squared equals, and it's got to be this whole thing, I got to square this whole thing. So put it in parentheses, that whole quantity gets squared. So this side is easy enough. But this side, I have to write it out twice, because if I have a binomial, right, I need to write it out twice so that I can FOIL it out. First outers, inners, last, right? So I'm going to get x squared plus 81 on this side, and then x squared plus x, that'll be plus 2x, plus 1 on this side. And since there's an x squared on both sides, those will cancel, right? And then I can just subtract my 1 over here and get 80, and then divide by 2, and I get 40, right? So there's my answer for that. So in the delta math, there will be some problems where you are finding the distance using the Pythagorean theorem rather than the distance formula. And they'll ask you to kind of like click and drag your triangle, right? So wherever your line segment is that you're trying to find the triangle, you can kind of click and drag in the x direction and the y direction and make a triangle. It could be like that, or it could be like this, right? You could make a triangle in this direction as well. Either way, the A and the B are going to come out to be the same length, the difference in the x's and the difference in the y's, right? No matter which way you put that triangle. And then you can do your Pythagorean. Just remember, leave it in radical form. Don't do the decimal form, right? So if I have a problem like this and they want me to create a triangle with it, I can either create a triangle on the bottom or I can create a triangle on top, either way, right? And then I can count 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side. So if I want to use Pythagorean to find this distance, then I'm really looking for this hypotenuse C. So 4 squared plus 4 squared equals C squared, 16 plus 16, so that's 32. And then of course you want to reduce it. That has a perfect square in it, right? So 4 times 8, ooh, that has another perfect square in it. 4 times 2, so that'll be 4 on the outside, 2 on the inside, right? And I would leave it 4 root 2 as my simplified answer. Okay, one more, same with this one. I can do a triangle on the bottom, I can do a triangle on the top. It doesn't really matter. You would just create your triangle with your x direction and, you know, as one of your legs, 1, 2, 3, 4, 5, and your y direction as your other leg, 1, 2, 3, 4, 5, 6, 7, 8. And then we'll do Pythagorean to find the distance between L and M. Okay, so we'll have 5 squared plus 8 squared equals C squared, 25 plus 64, so that'll be 89, which I believe is already something that can't be broken down. So square root of 89 it is. That's all we've got. All right.